Welcome. Today, we are going to tackle a big topic, building a really practical guide for institutional review boards, IRBs, on how to review AI research that involves human subjects. So if you're on an IRB, think of this as your new go-to procedure manual for a challenge that is getting more and more complex every single day. Let's dive right in.
So this is the million-dollar question, isn't it? As these research proposals involving artificial intelligence start landing on your desk, you're faced with a totally unique challenge. You're being asked to weigh the risks and the benefits of a technology whose decision-making process can basically be a complete black box. How do you do that?
And make no mistake, this isn't just some small update. It's a fundamental shift in how research is done. The AI systems we're seeing today are a whole different beast from what came before, and they absolutely demand a new framework for oversight, one that our old methods just weren't designed to handle. Yeah, this slide just nails the difference. On the left, you've got the old-school rule-based AI. Think of it like a giant flowchart. Every single decision was an if this, then that statement, hand-coded by an expert. You could trace everything. But on the right, you have modern machine learning. It uses these things called neural networks that learn from huge amounts of data, kind of like a human brain. The problem? We often have no idea how it really got from point A to point B. And this brings us right to what we call the opacity problem. Because these neural networks are so complex, their internal logic is often impossible to fully understand. And that lack of transparency is a huge issue because it means we can't easily check for hidden biases or flaws that could have really serious consequences for patients. It puts doctors in a position where they might have to just blindly trust the machine's output, and that's a massive ethical red flag. So on top of that opacity, you've got the data problem. See, an AI model is only as good, or as unbiased, as the data you feed it. If your training data has historical biases baked into it, or if it's incomplete, the AI is going to learn those flaws and just amplify them. It all comes back to that classic computer science saying, garbage in, garbage out. And check this out. This is the perfect example. There was a famous study where an AI was being trained to spot skin cancer, but it turned out that in the training data, most of the pictures of cancerous moles also had a ruler next to them for scale. So what did the AI learn? It learned to look for rulers, not for cancer. It was spotting the wrong pattern entirely, which just goes to show you how critical the right data and proper validation really are. Okay, so with all these challenges swirling around, let's get down to brass tacks. A research protocol with AI in it lands on your desk. What's the very first question you have to answer? When does an IRB review even need to happen for this stuff? Here's a super simple decision tree to help you out. First, you ask, can this AI be considered a medical device or software? Step 2, is the main point of the study to test its safety or how effective it is? Third, does it actually involve human subjects, meaning does it interact with people or use their private identifiable data? And finally, is this just for internal quality improvement? If you're checking the boxes on the first few and the answer to the last one is no, then yeah, you're almost certainly looking at something that needs a full IRB review. And just so we're all on the same page, let's ground ourselves in the official definition here. Human subjects research is a systematic investigation designed to create knowledge you can apply broadly, and it involves either interacting with people or using their identifiable private info. This definition, it's our bedrock. Everything else is built on it. Okay, so we've laid out the problem and we know when we need to step in. So, how we actually do the review? Well, the solution is a structured, risk-based approach that we're going to call the 3-phase AI framework. This approach breaks the whole AI lifecycle into 3 clear stages. You start with phase 1, which is discovery, then you move to phase 2, validation, and it all leads up to phase 3, the clinical investigation. Now, the key idea here is that the level of your oversight as an IRB should scale with the project. You don't need the same level of intense scrutiny for an early idea as you do for a tool that's about to be used with real patients. So let's start at the very beginning, phase 1. This is where the initial idea gets fleshed out, and the first very basic models are developed, way before they ever get close to a patient. In this early phase, you're not really looking at clinical outcomes yet. Instead, your review is all about the fundamentals. Does the proposal clearly state the problem they're trying to solve? What data are they planning to use? And, critically, how are they going to protect it? And what's the basic blueprint for the AI itself? You're basically making sure the foundation is solid before they start building. All right, now we move into the really crucial second phase. The model's been built, and now it's time to find out, does this thing actually work, and is it safe? This is where all the tough technical evaluation happens, usually in a totally offline simulated setting. Phase 2 is all about the evidence. You need to see clear metrics. How are the researchers measuring success? And this is so important, how are they looking for and measuring bias across different groups of people? Are they trying to break the model on purpose, stress testing it to find its weak spots? And are they using a brand new, unseen data set for this validation? This is how you start to peek inside that black box and really see what's going on. And finally, we get to phase 3. This is the big one. This is when the AI tool is ready to be tested in a real-world clinic, interacting with or making recommendations about actual human beings. The stakes are officially at their highest. For this last phase, your checklist needs to be absolutely airtight. How exactly is this AI going to be used with patients? What happens if the AI messes up? What's the safety net? How are patients going to be informed about the AI's role in their care so they can give truly informed consent? And what's the plan for tracking safety and effectiveness, not just during the study, but for the long haul? So, what does this all mean when we zoom out? Well, this 3-phase framework isn't just a helpful idea. It's actually part of a much larger global movement to create real standards and accountability for artificial intelligence. The work that you do in an IRB connects directly to these huge international efforts, like ISO 42001, which is the world's first ever standard for managing AI. The goal, as the standard says right here, is to mitigate risk and build trust. Your review process is the boots on the ground work that makes all of that possible. And really, this is what I want you to take away today. The complexity of AI can feel totally overwhelming, but it doesn't have to be. This risk-based 3-phase framework gives you a concrete step-by-step procedure you can actually follow. It turns this abstract, scary challenge into a process you can manage, and it empowers you to protect research participants while still allowing for responsible innovation. So, to wrap things up, I'll just leave you with this thought. AI is not a static thing. Its whole deal is that it learns and it changes. And that means our approach to ethics and oversight can't be static either. The real challenge ahead isn't just about reviewing the AI we have today, but about building an ethical framework that is flexible enough to evolve right alongside it.